Hey guys, how's it going? It's chapter 2 time. So this chapter is called The Chemistry of Life, and we are going to be recording. I'm going to try to do lessons 1 and 2 in this presentation here. So lesson 1 is called The Nature of Matter. All right, and you probably already remember these words. This is atoms, and in atoms here we're going to call them subatomic particles, and we know that they are protons, neutrons, and electrons. All right, so you can see in here that the protons and neutrons are in there, and then the electrons fall in the outer orbitals. Okay, so that's what those are, protons and neutrons, electrons in the outer orbital there. Okay. An element is a pure substance that consists entirely of one type of atom. So what would the atomic number be here? Anybody know? It is 6. The atomic number is representative of the amount of electrons in the outer orbitals. All right, and what is an isotope? Isotopes have the same number of electrons. All of the isotopes of an element have the same chemical properties. Okay, but what is going to be different about them? This is carbon 12, 13, and 14 we're looking at. 2 non-radioactive isotopes and 1 radioactive isotope used for carbon dating. Okay. It makes it an isotope because they do have a different number of neutrons. That is what an isotope at its molecular level will look like. All right, chemical compounds. Let me see if I can move this up. I'm sorry, it's a Friday afternoon and I'm very tired, so I'm doing my best to sound chipper in this video. A chemical compound is a substance formed by the chemical combination of 2 or more elements in definite proportions. The physical and chemical properties of a compound are usually very different from those of the elements from which it formed. Okay, so chemical compounds, for example, like salt or NaCl, sodium chloride, you are going to see an ionic bond in that particular type of compound. An ionic bond is formed when 1 or more electrons are transferred from one atom to another. So you can see here that the electron is going to be transferred from the sodium to the chlorine atom. All right, and so that would be minus 11 electrons to make the charge 0. All right, and then minus 17 electrons because there's 17 over here now, so the charge would be 0. So, because the charge is 0, they make this fun little combo over here called table salt. All right. Okay, covalent bonds are the other type of bonding we need to talk about. It's a bond formed when atoms share electrons. So the typical example is water, H2O. These are supposed to circle the hydrogen ions. All right, and we've got 8 electrons in oxygen and 10 total electrons, hence H2O. There's those 2 electrons that they are sharing is what it's trying to circle. Okay, a really cool concept in here is van der Waals forces. They are intermolecular forces of attraction due to a slight attraction between oppositely charged regions of nearby molecules. So this is the reason why you can see little geckos on their little toes. They have that slight attraction in van der Waals forces that helps them to create an attraction to a surface so that they can climb walls and things. So pretty cool little concept. I encourage you to Google it more. It's quite interesting. All right, lesson 2 is properties of water. Water is a pretty cool substance. All right, so water molecules are polar. The charges are unevenly distributed in the molecule. All right. So there's there's the negative charge and then the positive charges where the hydrogens are. All right, and hydrogen bonding is a very special bond. You can see these yellow ones here are the hydrogen bonds. All right, and the reason that animals like these little water gliders can float across the surface of the water is because of a word called cohesion, and that is because water is a special molecule. Cohesion is the attraction between molecules of the same substance. Okay, you'll see surface tension really here is what this is showing you. Okay, and adhesion is the attraction between molecules of different substances. So, adhesion is the response why water can stick in these capillary tubes that you'll see here, and I'll do a little demo for you guys of penny on a water. Wow, water on a penny, and how it creates a nice bubble on the surface of it. So water molecules being attracted to another surface is adhesion. Cohesion would be water to water, whereas adhesion is water to another surface. These are little capillary tubes, and if you take a little glass tube like that, it's like a little itty-bitty straw, and you tap the top of it, the water would move on up, just like capillary action is another example of how plants' roots absorb the water and suck the water up into them. All right, and you'll see the fancy word here, meniscus, is that little surface tension, and you see the adhesion attaching to the walls here. All right, water is special also because it has a heat capacity that is higher than a lot of other substances. The amount of energy needed to raise a substance's temperature by making its molecules move faster. So, boiling point would be what we're referring to here when we boil water. It does take quite a bit, right? So that means that it does have a higher heat capacity than other substances that are liquids. All right, and then solutions. Water's polarity gives it the ability to dissolve both ionic compounds and other polar molecules. So the concept here they're trying to get you to think of is like dissolving sugar in water when you make sweet tea, right? In this case, they're using salt, and you can see that the salt is dispersed in the water, and that is going to make it a solution. Okay, and everybody's pretty familiar with this, I hope. There will be some little activities in the classroom to help you remember the pH scale. We've got low pH, means that it's acidic and has higher hydroxide ions, and pH of a higher pH would be basic, which means lower concentrations of hydroxide ions, or H+. So water is typically neutral. Human blood is a little bit basic. Okay, bleach, very basic, versus lemon juice, which would be very acidic, or stomach acid, or tomatoes. Okay. Buffers help to maintain homeostasis in organisms. All right, so what we want is the buffer to be creating a neutral balance. A lot of times I used to use buffers in my saltwater fish tank at home so that I could maintain the pH level properly, and then that's also related to alkalinity, but that's an environmental science topic. Okay, so the unbuffered base plus acid means that it's going to yield an acidic pH. And the buffered base and an acid, can you see that down there, means that it will yield a basic pH. All right, I'm going to stop there, and I'll post the lessons 2 and 3 in another segment.